Located approximately 2,600 light-years from Earth, a remarkable phenomenon is unfolding in the cosmos. An aging star is shedding its outer layers, creating what scientists refer to as the Ring Nebula. Thanks to the James Webb Space Telescope, we now have stunning images of this celestial event. Imagine a glowing gas donut, that's the Ring Nebula up close. Join us as we explore the question, where is the end of space? And uncover some astonishing secrets of the universe, all made possible by this remarkable telescope. The James Webb Space Telescope has made a bold claim. It has discovered the end of space itself. This assertion challenges the long-held belief that the universe extends infinitely. But how can space have a boundary? Isn't it supposed to stretch on forever? Let's take a moment to grasp the universe's sheer immensity. The observable universe spans about 93 billion light-years, containing over 100 billion galaxies. It's mind-boggling, isn't it? But let's get back to business and see what the James Webb Space Telescope has actually been able to see out there. Exploring the limits of the universe. First stop, the edge of our solar system. Passing by planets like Mars, Jupiter, Saturn, Uranus, and Neptune, we've traversed significant ground. Now, we stand at the threshold of the heliosphere boundary. Beyond this point lies interstellar space, where brave explorers like Voyager 1 and 2 have ventured. Next, we navigate past the Oort cloud, a massive collection of icy bodies about 200,000 astronomical units from Earth. It's an eerie journey through the darkness, but we press on. Zooming past stars and planets, we soon reach the edge of our own galaxy. Here, no more interstellar breeze, just a dazzling array of distant galaxies mapping our route. But here's the fascinating part. Our universe isn't an endless void. It has its limits, estimated to be about 10 billion light-years away. There might even be other universes beyond our own. Some scientists theorize that the original supervoid, a billion light-years wide, could indicate a collision with another universe. As for reaching these other universes, black holes might hold the key. They are like cosmic gateways, warping space and time in mysterious ways. Some experts even suggest the existence of white holes, the opposite of black holes, potentially leading to entirely new realms. Remember that peculiar burst of energy in 2006? Some speculate it was a baby white hole, gone in the blink of an eye. Fascinating, isn't it? Now let's consider another mind-bending phenomenon, the Andromeda Galaxy. It's hurtling towards us at a staggering 68 million miles per hour. While it's not an immediate concern, its eventual collision with our galaxy will be a spectacular event to behold. Wonders and mysteries. Stellar collisions could light up the sky, potentially flinging our solar system into the darkness like a tennis ball on a fast-moving rope. But this is just the beginning. Fast forward to the grand merger of galaxies. As they coalesce, the black holes at their centers engage in a mesmerizing dance, eventually merging into a supermassive black hole. This merger unleashes tremendous energy, creating an active galactic nucleus visible for millions of light-years. Consider some of the other astonishing structures in the universe. The South Pole Wall, located 500 million light-years away, contains a quadrillion stars. Then, there is the Hercules Corona Borealis Great Wall, a colossal flat superstructure stretching 10 billion light-years across. Additionally, the huge Large Quasar Group spans an impressive 4 billion light-years and weighs 61 billion times more than our Sun. The observable universe itself contains over 500 billion galaxies, each with billions of stars. Among these wonders is the Eridanus supervoid, or the cold spot, stretching a billion light-years wide. Some scientists speculate this void could result from a collision between universes, like two bubbles touching and tearing material away. The universe may be one giant bubble containing infinite smaller bubbles, wormholes, or portals. Black holes could potentially serve as shortcuts between these universes, akin to folding a piece of paper to connect 2 points without traversing the whole sheet. Further intrigue lies in the fate of those who fall into black holes. Surprisingly, falling into a supermassive black hole might be survivable, as the gradual increase in gravity's effect avoids the dreaded spaghettification. Surviving such a fall might lead to another universe with different physical laws, although this remains a speculative theory. On a clear night, the stars may seem evenly spread out. However, they are part of a massive cosmic web connecting galaxies across the universe. This cosmic web underscores the intricate and awe-inspiring nature of the universe. A James Webb Space Telescope discovery. Astronomers, using the James Webb Space Telescope, have stumbled upon what could be the oldest strand of the cosmic web ever discovered. In 2 papers published in the astrophysical journal Letters, scientists detail this incredible find. Using data from the James Webb Space Telescope, they uncovered a colossal tendril composed of 10 closely packed galaxies, stretching over a staggering 3 million light-years. Xiaofan, an astronomer from the University of Arizona and part of the research team, expressed his astonishment. "I was surprised by how long and how narrow this filament is. I expected to find something, but I didn't expect such a long, distinctly thin structure. It's like stumbling upon a hidden ancient treasure in the cosmic vault." This ancient filament of gas and stars dates back to a mere 830 million years after the Big Bang, during the universe's infancy. Anchoring this colossal thread is a supermassive black hole, a quasar, an extremely bright celestial object that serves as the anchor for this cosmic structure. The team behind this groundbreaking discovery is part of the Aspire project, which aims to understand how the earliest black holes influenced the evolution of galaxies. Their investigation led them to this ancient filament through one of the 25 early universe quasars they were studying. Fang Wang, an astrophysicist from the University of Arizona and the leading mind behind Aspire, exclaimed, "This is one of the earliest filamentary structures that people have ever found associated with a distant quasar. It's like they stumbled upon a cosmic treasure map, revealing secrets of the universe's early days." The researchers hypothesized that black holes played a crucial role in forming this cosmic web, acting like magnets that draw matter together with their gravity, while occasionally flinging material away with cosmic winds. Gravity serves as the glue that keeps these strands of stars and dust connected, even as cosmic winds attempt to disperse them across the universe. Looking ahead, the researchers believe this ancient filament will eventually condense into a cluster of galaxies similar to the Coma Cluster, located about 330 million light-years away from us. It's like observing the universe evolve and create its own intricate masterpiece over millions of years. When the Webb telescope focused its mirrors on a patch of sky, it observed far more light and many more galaxies than anticipated. Not just any galaxies, but large, bright ones. Now, scientists are pondering various possibilities to explain this cosmic mystery. New possibilities. These possibilities present various avenues, each leading to new questions and insights. One possibility is that stars and galaxies formed differently and more efficiently in the early universe. Another possibility is that the observed brightness is not from stars but from supermassive black holes. Instead of galaxies illuminated by stars, we might be seeing galaxies lit up by these mysterious black holes. If true, this challenges our current understanding of how many of these black holes existed in the early universe. The most extreme possibility is that our understanding of cosmology, the universe's recipe book, is incomplete. This radical idea could significantly alter our comprehension of the universe. Additionally, there might be an unknown component of the universe that we have yet to consider. Why does all of this matter? It is about finding our place in the cosmos and understanding the story of how we got here. If we are missing something crucial in this story, it is like trying to solve a puzzle without all the pieces. The more we investigate this mystery, the more questions arise. Recent findings from the James Webb Telescope have provided a reality check regarding the size of the universe. Scientists recently claimed that the telescope observed phenomena occurring just 120 million years after the Big Bang. This challenges the very foundation of the standard cosmological model and disproves Einstein's idea of an infinitely old universe. The James Webb Telescope can observe space up to about 46.5 billion light-years away, known as the Hubble radius or Hubble sphere. The most distant galaxy ever discovered by the telescope, Macy's galaxy, existed just 450 million years after the Big Bang and is still within this Hubble sphere. F200DB045 and the enigma of cosmic origins. Now picture our universe as a balloon that's constantly getting bigger. Not only is it expanding, but it's also accelerating in its expansion. Beyond the Hubble sphere, the universe is stretching out faster than the speed of light. But the Hubble sphere won't keep growing forever. There's a cosmic horizon limit, a fancy term for the observable universe. Imagine a gigantic imaginary shell around us, 93 light-years wide. That's our limit, the farthest we can see anything. Beyond that, sorry, not visible yet. So how big is the entire universe outside our cosmic shell? Well, we don't know for sure. There are competing theories, but some suggest it could be infinite. Yeah, you heard it right, infinite. When we gaze into the vastness of space, we're not just looking at distant galaxies. We're sort of peering back in time. Those galaxies we see near the Hubble sphere. They're like cosmic fossils, remnants of a bygone era billions of years ago. According to our cosmological model about 14 billion years ago, the entire observable universe squished into a tiny point called the singularity. But if the universe is infinite, which it kind of seems to be, then the Big Bang wasn't a localized event. It happened everywhere. Now, just when we thought we had the universe's biography sorted, the James Webb telescope stumbled upon F200DB045, a galaxy that could rewrite cosmic history. This galaxy is so distant that if confirmed, it would challenge our cozy 13.8 billion-year-old universe narrative. Now Webb has found galaxies that shouldn't exist. I'm talking about massive galaxies appearing just a few million years after the Big Bang, a cosmic speedrun that defies our current understanding. Even more jaw-dropping, the telescope caught early black holes only 700 million years after the Big Bang. Black holes merging left and right possibly explain how these cosmic vacuum cleaners grew in their toddler years. These discoveries are stirring up some cosmic chaos in the world of cosmology. The universe might be older than we thought, or it might not have had a beginning at all. Imagine if our universe is like that favorite storybook that never had a first page. It's always been there, just unfolding through different chapters. But we need more research. Does this eternal universe jive with our current scientific groove? Can it explain the intricate dance of events during the Big Bang? There might be around 2 trillion galaxies out there, but astronomers are scratching their heads, wondering how much more of the universe is out there beyond what they can see. So what's the plan? Well, astronomers are hoping for a lifeline from theory. They want a model that can indirectly prove whether the universe is infinite or not. It's the hope that a well-crafted theory will point us in the right direction, helping us unravel the cosmic mystery that's been boggling our minds since Galileo's first telescope pointed skyward.